Is chemical kinetics, chapter number 4, class 12th. Welcome to Teaching with Panchal. In first lecture we were studying that the integrated rate equation for zero order reaction. The reactant change into product, the rate is the minus dr by dt, k r raised to power 0 because of the zero power of the zero order reaction. So r raised to power 0 means the unit is equal to 1. So dr is equal to minus k dt and r is equal to minus kt plus I. We can get by integration of both sides. So today we can start the first order reaction. In the first order reaction, the rate of reaction is directly proportional to the first power of the concentration of the reactant. So now we can start. The rate of reaction is directly proportional to the first power of the reactant. Now the reactant is changed into product. The rate is equal to minus dr by dt is equal to k r. Now change the sign of minus dr to dr and r replace here. R is equal to k minus k dt. Okay, so now integrating both sides. So dr by r we get ln r is equal to minus kt plus I, where I is the integration constant of integration also. This is the very important topic really for board examination also, where t is equal to 0. At that time r is equal to replaced by r naught, where the r naught is initial concentration of reactant. So now in equation first, get the first equation here. So replace the ln r is equal to r naught and t is equal to 0. Substitute in equation first. So ln r की जगह r naught आ जाएगा. ln r naught is equal to minus k into 0 plus I. So ln r naught is equal to I. So this gives the equation 2. Now ln r equation first, right? ln r is equal to minus kt plus I. We replace here. So ln r is equal to minus kt plus I की वैल्यू इधर से सब्सटीट्यूट करेंगे. I is equal to ln r naught. Now ln r upon r naught is equal to minus k into t. We replace here. So value of the k is equal to 1 by t ln r naught by r. Now we take this third equation. So at the time of at the time t1 ln r1 is equal to minus k t1 plus ln r0 at time t2 ln r2 is equal to minus k t2 plus ln r0. So we subtracting equation here, fourth and fifth, we can get ln r1 minus ln r2, so minus kt1 minus k t2. Now the value of k is equal to 1 by t2 minus t1 ln r by r1 by r2. So here we get the value of k. Now the equation, the ln, you can see here ln r upon r0 is equal to minus kt. So taking the antilog of both sides, ln r by r0 is equal to r0 e minus kt. Now the first order reaction rate equation is the value of k is equal to 2.303 t upon log r0 by r. By changing the ln to the log, so we can get 2.303 upon t log r0 by r. So log r0 by r is equal to kt upon 2.303. So we can put the graph of log r0 by r versus t. So we can get the slope is k 2.303. This is the compare equation of y is equal to mx plus c. So now we take the reaction first. For example, C2H4 gas plus H2 gas converted into C2H6 gas. Now the rate of reaction is equal to k constant C2H4 k into reactant. So here we complete the derivation of the first order reaction. Now we study the line by line explanation of the first order reaction in textbook. I recap that the first order reaction, the rate of reaction is proportional to the 1 minute. The rate of reaction is proportional to the power of the reactant concentration. Here the R reactant is changed into product. Rate is equal to minus dr by dt is equal to k into r, or we replace the dr here, dr by r, then the value minus sign is changed here and minus k dt is replaced here and r here, so dr by r is equal to minus k dt. We can integrating both sides, so we can get the ln r I is equal to minus kt plus I, where the I is the constant of integration. Now at the time of t, r is equal to r naught, so we put the r is equal to r naught in equation first. So ln r naught is equal to minus k into 0 plus I, where ln r naught is equal to I. So we replace the first equation again and get ln r minus kt plus I. The ln r minus kt plus value of I is equal to ln r naught. Here from second, so ln r upon ln r naught is equal to minus kt, or k is equal to 1 by t, r naught by r. At the time of t1, ln r1 is equal to minus kt1 plus ln r naught. This given by this equation. So at time t2, ln r2 is equal to minus kt2 plus ln r naught. Substituting these two equations, we get the k is equal to 1 by t2 ln r1 by r2. So now the ln r by r naught is equal to minus kt, taking the antilog of the both side, and we get the r is equal to r naught e minus kt power of the minus kt. First order reaction equation is k is equal to 2.303 d log r naught by r. We change the log r naught by r here, and the value is kt. T is changed here and 2.3 here, so we get kt upon 2.30. The slope of the line is equal to k upon 2.303. So in textbook, here we can also derivate the rate r is equal to r, reactant changing into product kr and minus k dt, integrating minus kt plus I at the time t, and r is equal to r naught, ln r naught is equal to r ln r naught plus minus kt. So we completed this one also, ln r2 at the time t2 minus kt2. When the substituting these both equation, we get k is equal to 1 upon t2 minus t1 ln r1 upon r2. So ln r1 upon r2 is equal to minus kt. From the equation of this, ln r1 minus r2 is equal to minus kt. So taking antilog and getting r is equal to r naught minus kt. Now the slope of the first order reaction is k is equal to minus slope ln r naught r2 t, and when the log r naught by r, then the slope is in increasing k upon 2.303 slope of this, and when the ln r upon t versus graph, then we get the k is equal to minus